Alright, today we're going to talk about limiting reagents. Now, with stoichiometry, we can figure out how much we make, and that's kind of an important thing. But sometimes we have things that are going to limit what we can make. So if I was working at a bicycle factory and I wanted to make 100 bikes, but I only had 100 wheels, 100 tires, I couldn't make 100 bikes. Okay, because my tires would limit me. I can make 100 unicycles, but it's not a unicycle factory, it's a bicycle factory. So, things will limit us. We need to figure out what limits us and how many we can make. So, what we got here is we have a reaction of 5S2 or AS2O3, which is diarsenic trioxide, plus 4 moles of HiO3. Plus 13 moles of H2O, and that yields 10 moles of H3AsO4 plus 2I2. Now in this particular reaction, I want to figure out how much iodine I can make. So we're going to figure out that from these amounts here. Now, I don't have amounts here, so let's go ahead and throw some amounts in there. Now, you can't see him, he's off the screen, but Dakota's in the room. Dakota is playing the home version. He is going to give me amounts so they're not made up on the spot. Dakota, I need an amount for AS2O3.
3.
I have 3 grams of AS2O3. Alright, Dakota, HiO3.
4.
4 grams. And how much H2O?
9.
Alright. This is the amount that I have. I have 3 grams, 4 grams, and 9 grams. Alright, I need to figure out how much I can make from these totals. There's a couple different ways I can do this. I can convert this into moles, and then I figure out how it fits in the ratio. Now, for some of you, I'll actually probably work with you in class, and we'll probably work with that. And you'll think, why didn't you show me this from the beginning? Well, I'm going to go over this as a whole, and do some things that just will give you some more practice with stoichiometry, but it'll also ensure that you get the right answer. So if you really want to try a different way, come ask me, I'll show you how to do that way. But I'm going to show you the one way that is guaranteed to give you the right answer. Alright, so if I have 3 grams of AS2O3, I've already taken the time to write this down. So let's go ahead and start our stoichiometry problems here. So if I have 3 grams AS2O3. I'm just going to mark these over here so I know where I'm going. Alright, I need to get this into moles, because every time we're doing these problems, I always have to go to moles. I'm not even going to write in stuff yet. So this is going to be grams of A2O3, and that is going to yield a mole of A2O3. Zach, can you get a clear shot of that? Make sure it's nice and visible for the kids at home. Alright, whenever we're getting rid of moles, I want to go from moles of that's not A2, that's AS2. Let me write that correctly. Now I'm going to go from moles of AS2O3 into moles of I2. Remember the numbers in front, those are just our moles. So I have a mole ratio. For every 5 moles of AS2O3, I'm going to make 2 moles of I2. So that's a ratio. I can be able to figure that out. So moles AS2O3 into moles I2. Okay, I don't want moles. I want to know how many grams I can make, because I started with grams. If it doesn't ask you any other thing, we're going to go straight to whatever one we started with. So we're going to go to grams here. Moles of I2 we want to get rid of, and we're going to go to grams of I2. Alright, I've got it all set up. I know exactly where I'm going. Now we need to put numbers in there. Moles with the gram is always going to be 1. Now I've taken the time and I've actually figured out what a molar mass is ahead of time. So use your periodic tables to figure molar mass. You know how to do that. But I know that AS2O3, Zach, can you see me? We're good? AS203 is 197.8414. Okay, and that's in grams. Now my mole ratio step, I go to my table up here. I have 5 moles of AS203 for 2 moles of I2. I have a mole and a gram together, so that's 1 mole. And my grams of I2, I didn't take the time to do that, but let's call it 127 times 2, 254 grams. Okay, so when I do the math here, this will predict how much I2 is produced. So 3 times 1 times 2 times 254, multiplying straight across the top, divided by 197.8414, divided by 5. I should be able to produce 1.54 grams of I2. Okay, that's one of them down. This next one, HiO3. I have 4 grams of that. I want to set up the same situation here. Okay, so we're going to try to move a little bit quicker. Okay, I've also got HiO3, its mass done. It's 175.91032. And notice I am taking the time to show my units in here. And that is in 1 mole of HiO3. Anytime we're switching, we've got to go ahead to the mole ratio step. In this case, it's a 4:2. This last step is going to be identical because we are already in moles of iodine. We know what our mass is over here, so we can use the same thing. No new information. So I'll do the math there. And I can produce 2.89 grams of I2. Alright, and the bottom one, our water, which we start off with 9 grams. Three parentheses once more. Our mass for water is 18.01528 grams, and that's still water, and that's 1 mole. Now we go to our mole ratio step, this middle step. There are 13 moles of H2O. And it's the 3rd time we've done iodine, so each time we do iodine, it still goes back to our mole ratio step. It's going to be 2. And our last bit of iodine is going to remain the same. 254 grams of iodine over 1 mole. So 9 times 2 times 254 divided by 18.01528 divided by 13. Holy cow, I could produce a lot of iodine if I had that much water. Alright, those are the amounts that I could produce with those things. Now, only one of them, though, is going to limit us. There's going to be one that's going to stop the reaction first. Okay, the one that stops the reaction first is going to be the iodine, or not the iodine, the AS2O3. Because I can only produce 1.54 grams of iodine if I have that much. Everything else is going to be in excess. It means I have too much of it. So if I was running a business, I wouldn't want to order extra of this, extra of the HiO3 and extra of the water in that case. Because if I had extras, I had too much of it, that would cost me money. We don't like to waste money, it's a bad thing. So if I can figure out how to get these in the correct ratios and make the correct product, things are good. Okay, we'll talk about that a little bit more on some of your questions, but the one that gives us the lowest number, that is our limiting reagent. All right, we'll see you guys tomorrow. Have a good evening.